In this video, we'll be using MySQL, which is a typical relational database management system or database to wrangle the New York City Airbnb dataset, which is a publicly available dataset from kaggle.com. Then we'll be using our MySQL library or package to connect to this MySQL database from R. Then we'll use SQL, which is just a programming language which has different commands or statements to query and manipulate the data. But before we continue, I'm going to switch to the visual tab here just for easier presentation and analysis of our data. So a little bit background on MySQL, pronounced MySQL. This is an open source relational database management system widely used for building and managing databases, right? So here we use the SQL, abbreviated SQL, just stands for structured query language. And this is just a programming or query language to allow us to interact with the databases and perform operations such as, creating, modifying, retrieving, and deleting the data. So what's SQL? This is just a programming language that allows us to communicate and manage relational database, right? And some of these relation databases include MySQL, which we're going to be looking at in a few minutes here, Oracle, Microsoft SQL Server, SQLite, which we've already reviewed in another video, and Postgres. Okay. So essentially what SQL does is to allow users to define, manipulate, and retrieve data stored in a relational database, right? In a few minutes, we'll see how we can download our data and actually, store it in a MySQL database. Okay, so we do have quite a bit of commands that we're gonna use for creating, modifying, and deleting commands. Again, if you go to this website on W3C Schools, you can see all these are just different commands that that are available, and they just have different examples which you could try. We'll come to that in a minute. So what are some of the reasons why SQL here, MySQL, or why SQL is widely used for managing relational database? The first point here is that data management, right? So given that it has a comprehensive set of commands for creating, modifying, and deleting tables, which includes inserting, updating, and deleting data in the database. This just provides us a platform to efficiently organize and manage large amounts of data. Also, in terms of data retrieval, SQL here, or SQL, provides us a facility for querying our database and just allows users to ask different questions by retrieving data based on conditions or criteria, such as filtering, sorting, and also performing aggregate functions on our data. This just allows us to extract meaningful insights from large data sets. Okay. Data integrity, also during creation of our table, we can enforce different constraints like primary keys and foreign keys. This just allows our database to remain accurate, consistent, and reliable. In terms of scalability, again, SQL databases are highly scalable. What that means is just that it just can handle very large data sets, right? Meaning that also it can support concurrent access by multiple users or threads or processes or applications. The other two is interoperability and security. Again, here, MySQL here just has a security feature where you can actually, safeguard who accesses your database using user authentication and also some amount of data encryption. So a little bit about the dataset. This is the New York City Airbnb data, which is publicly available on kaggle.com. As you can see here, this is a very large dataset. It's about 7 megabytes. Right, and you can see these are some of the columns that we have. We have price, minimum. We're gonna see 16 columns in total, right? So, and these are some of the variables. So ID here Again, in brackets, we can see the different data types. So this is actually numeric or integer. It's just a unique identifier for each A and B listing. The name here just refers to the title of the A and B listing. Unique identifier for the host ID, host name, name of the host of the A and B listing. The neighborhood group, this just means where the A and B listing is located. Could be Manhattan, Brooklyn. Latitude and longitude just gives us the coordinates of the Airbnb listing. Room type can be private room or entire home. The price in dollars, again, nightly price on of our the Airbnb listing. Minimum nights that is listed in those Airbnb. And then also we have the number of reviews per month, availability throughout the year. Just the number of days would be 100, or is it available throughout the year, and so on and so forth. Now, in order to replicate this demo, the first thing you want to download is the MySQL community server, right? So if you go to Google and type MySQL download, again, what we are interested is this community server will automatically detect your operating system. So I went ahead and downloaded the DMG. If you're using Mac, it will come in this format, right? Double click on that, and then we'll just take you through different processes, right? Just keep doing that, and it will ask you. So the only thing that you need to keep in mind is it will ask you for a password. So we'll come to that in a moment. And then the next thing is to install the MySQL Workbench, right? So again, just make sure you can download that, because this just gives you a graphical user interface that allows us to interact with MySQL community server. So once we have that, it will look like this. So again, as you can see, this is the graphical user interface for MySQL server. It just allows you to browse the database schema. So the next thing here, so during installation, just make sure you can actually use this this kind of password, password, right? The user will be root. Okay. So again, so just double click on that, and you can see now I can put my password here now. So this would be p@ssword. Okay. So once I have that, again, now I'm inside the Workbench, right? So I could come and click just to see what we have here. There are different things. You can look at the server status, you can look at the client, and so on and so forth. Okay. Our schema here. So this is where we're going to create our database. So once we have that, the next thing you want to do is to download the New York City Airbnb. I'm just going to provide a link to the download, and then the next thing is to install the necessary packages. So in our case, you're going to use this. Again, to install that, you can actually click install here. MySQL. Again, we've already seen this when we're looking at the SQLite demo, right? So once you install that, just gonna load the tidyverse. I already installed that, just especially if I want to interact with the console, just to show you some R commands or functions. Then here is just to allow me to load the Airbnb data from my path folder that I already have in my app project that I call R analysis, right? So once you do that, you can run that. The next thing is to go over this code. So I'm just going to quickly go over that code. So the first thing here is the, so we have this function called DB connect, right? So the DB connect here, essentially, this is just a function in R that's used to establish a connection to a database, right? And it takes several arguments. In fact, it takes 4 arguments, right? So the first argument here is what we call the driver here. So this is the name of the database driver to use. In our case here, we're just going to specify MySQL, right? And then comma, we have host, right? Host here just means where the database is located, right? Equals to local host if it's on your local machine, right? And then the last two, or rather user and password, we're just gonna put exactly as we already kind of logged in using here. And then the DB name, again here, your DB name here is very important because this is just an argument that specifies, the name of the database you want to connect to. In this code, this is set to NB. And you can see here, we can create that over here. So for now, let me just drop this for now. So I'll drop this schema just to show you. So I'm going to drop that now. Then we can actually create a new schema here. So to do that, so we're just going to go and create a new schema here. And we can call that A and B, right? A and B and B, right? So we go ahead and do that. So once we have that, so that's okay for now. Once you type in the name of our schema, click on apply, and then we can click apply here. That will be executed. So already we have our schema over here. Yeah. So let's go back to our code, and that's what we have. And then the last piece of code here. So we have DB send query. So this piece of code here is just a function in R that's used to send a query to the database that we just created. So again, this will just take the following arguments, right? So it will establish our connection. So we use the con here. The con here basically is just the connection that we're gonna that we already created here. Yeah. So again, so this is used just to send this SQL query, right? So we set global local infile equals to true here to the MySQL database through the established connection, right? So essentially, this piece of code just enables the use of the load data in file, for example, statement in MySQL. This allows you to load your data from a local file into the database, right? So this query will be sent to the MySQL server using this DB send query function, okay? Now that we have that, let's go ahead and execute that. So essentially, this will just allow to authenticate our username and password. So this just shows us that we are successful. Then we have this CRUD commands in SQL. CRUD just is an acronym for create, read, update, and delete. Again, it just represents some of the basic operations performed on a database, right? On data in a database, right? So we're going to look at all this, insert into, select, update, delete. All these are different commands that perform different operations. Like delete here, we use to remove data from a table. Update here, we modify existing data in a table. And select here just can be used with different other clauses, just to retrieve different data for one more tables. So the next thing now is to load our CSV data into a data frame. So again, just going to use this function from tidyverse, right? Here, we just extract our CSV from our data folder, right? In our file organization over here, okay? So again, once we do that, we store it here as a data frame. So we execute that. So that's successful. So the next thing here is to create a table in MySQL. Remember, we've just opened a connection. So to do that, we're just gonna replicate all this. This is how just to create. So I'll spend a little bit time here to explain that. So essentially here, so for example, the ID here just means ID is just the name of the column, right? And then we specify the type. Right, so the integer here just means the integer column with the maximum length of 11 digits, right? And then we define it as an auto increment, meaning the primary key here is auto incrementing, right? And then the primary key here, they're just unique, primary key columns uniquely identify each row in the table, right? So that's what it means here. The name here, again, the data type here is varchar, meaning that it has a maximum length of 255 characters, and it means it cannot be null, right? So this is a referential constraint integrity. We want to make sure that it must have a value. Host ID here, again, we're just saying integer column with a maximum length of 11 digits and which cannot be now. So we keep on doing this, specifying the name of the column, the data type, and a little bit of some constraints that we want to enforce, that column cannot be null. So especially when you're doing some data entry, you know, it will ask you to enter some data, right? So once we finish that, at the bottom here, we have the primary key here. So primary key here is just to mention that our first column here is the primary key. So that means each of those observations, each of those rows will be unique to each of all these different entries. And once we have that, then we're going to be using the DB send query, right? So the DB send query here just allows us to send this SQL statement. So just allows us to send. So actually, this is actually an R function, right? It takes 2 arguments, right? So it just allows us to send a query to a database using a database connection, which is con, and then our query here is this object here, right? And execute that to the connected database. Our connected database is over here that we already opened that connection. And that's it. So once we create that, so let's run that. So if I go back here, you can see we don't have anything at the moment, right? The table is just empty. So we're going to create this table. So once I execute that, it will execute that, and we can see we got some message here, meaning it's successful. So I refresh this again, and you can see now we already have a A and B table. We can view the columns that have already been created, right? We can see here ID is int, and this is primary key. Name here is varchar, and so on. And so this is pretty cool if you think about it. So we already explicitly specify that here. All right, now, so let's insert some data into MySQL. So we're going to insert this data based on the CSV file that we already loaded. We're going to use this function, db writable. So this db writable function, right, is also a function in R that is used to write data to a database table, okay? And it takes several arguments, right? So the first argument here is con. We've already seen this. This is a variable that represents the database connection object, okay? So usually we use db connect. As for here, we can see we use db connect to connect to a database, right? So again, so once we have that, the next thing here, this is just a character string, right? That specifies the name of the database table. In our case here, this is the name here, right? In our schema here, this is the name that we want to specify. So we specify that as a character string here, okay? So this is what it means. And then the next one here, so the next NB here, this is the R object that we loaded into a CSV file here. So this is the data frame. It could be a data frame and so on and so forth. So this is where we want to load the data from and then insert into our schema here. And then row.name equals to false. Here again is just an option parameter. Specify whether or not to include the row names. In our case here is false, since we want to make sure that the row names will not be included in the written data, right? And then override here equals to true. Essentially, it's another optional parameter. We want to specify whether or not override the existing table. So let's go and write now some data. So we do that. Again, that's true. So we have some data. Good. So now we are ready to perform some basic data wrangling, right? So the data here, we already have some data now in our database. So that's pretty cool. You can see now. So we're going to do some wrangling over here. So the first thing here is to use this function. So next, we're going to be using the DB query here. So again here, this is just a function in R that typically is used to send a query to a database and to retrieve the results, right? Again, this function is very common to databases such as MySQL, Postgres, SQLite, and so on and so forth. It takes 2 arguments. So the first argument here is the connection, database connection, abbreviated as this object con. We've already seen this. Con just already includes all this, right? Okay. Oh, so let me just do that. So again, that's just your connection, right? And then the next argument here is your SQL. So SQL query, which is executed into, in this case, this is just, we are describing our A and B data set. So if you recall, in R, we use structure, right? So if we run this, it just tells us the different data types. So if you recall, again, this is just like using str, like str here for A and B for our data frame. Yeah, so it just tells us the different data types and so on and so forth. Again, so this is very useful if we want to just look at what data types are associated with these column names. And then here, if we want to show the tables, so we just use this SQL command, show, and then tables. We do that. We can see now we only have one schema that we already created. Very well. So the first command here is select statement. It's used to retrieve the data from the database, right? And the first thing here is to now retrieve all the columns from the table, right? So we're going to be using this a lot. So I'm going to be, I'll be talking more about the SQL statements, because this will remain the same for most of the codes over here. Yeah. So the second arguments are SQL here, right? So here, this select here will retrieve data. Then the asterisk here just means retrieve from all the columns. Remember the columns we created here? So we are not specifying any column. So we'll just retrieve from ID all the way to availability 365, right? And then from here just specifies the table that we want to extract that from. And that's the table that we just created. That table is just this one here, right? Or in our schema, this is the table we want to get the data from. So once we execute that, you'll see that we'll take some few seconds over here, and you can see now we already have retrieved 48, almost 49,000 rows. That's a huge amount of data, right? Okay. In fact, if I just do dimension here for A and B, right, you can see actually we have the same thing here. So we have 16 columns and 48,000, and this is actually a data frame, right? And we can scroll across all these different columns. You can see the neighborhood group, Manhattan, Brooklyn, and so on and so forth. Longitude and latitude. So again, we can see the price ranging from 200. We have 149. The room types, private, entire, and so on and so forth. So so that's pretty good. Again, the select statement can be used to select specific columns. So let's say we want to just to select the ID name, host name, neighborhood group, neighborhood, latitude, longitude, room type. So we can specify all that by separating that with a comma, and then we just say from our table, right? In fact, if you come here, SQL, and click on select, you can see this is the syntax, right? So you want to select, and then the columns are separated by a comma. From this a reserved keyword, and then the name of the table. Then you can terminate with a semicolon over there, or rather, semicolon. Okay. So in our case here, we don't need to put that, but it's okay. So once we do that, it will just retrieve the specific columns, right? So that's how to do that. The next thing here again is also specify a trimmed version of the same. So here we can specify 4 columns: ID, name, neighborhood, price, and you can see we have all that. All right. So the next example, let's say we want to retrieve rows that meet a certain condition. So in addition to select from, we're going to use where. So this where clause, if we come here, is used to filter the records, right? So all we need to do is to provide a condition here. So let's look at an example here. So we are saying here, select everything from that table called NB, but we want to specify a condition based on a column. So we know that the neighborhood group here, so let's say neighborhood group here, we have Brooklyn, Manhattan. So let's say we want just to extract everything from this table, but they should correspond to Manhattan. And then we can use AND here to combine 2 columns that have conditions. And we want to just retrieve all the listings in Manhattan that have a price that is greater than 200. So this is what that means. So again, notice how I'm using my column here, right? It still works. If I remove that, it still works at the same time. Yeah. Okay. So again, if we go to price here, you can see the condition here, all this. So essentially here we have over around 6,000 records that match this criteria, right? All the listings in Manhattan and all the listings in Manhattan that have at least price that is greater than $200. Okay, so pretty good, can be very good to answer the if questions. How about if we just want to retrieve only the unique names, right, from our NNB table where the price is greater than 200? Okay, so to do this, we're going to add this distinct. So this distinct here is used with select distinct. Okay, used to return only distinct different values, right? So just use these keywords, select distinct, and then the column 1, column 2 from the table name, right? That's what we're doing here. So we just want to select all the distinct names from NB with price greater than 200. So we can see here, there are about 8,000 distinct names, right? Meaning that they are not duplicated. So as you can see here, these are the different listings. So you can see perfect for your parents, plus garden, lovely EV artist home, and very interesting. Yeah, so, and you can scroll to see all the distinct names, right? All right, so again, in R, I think you can use unique over here, NB, I think like that, $sign. Then if I say name here, again, as you can see, we're able to retrieve about, different, so here we just kind of just truncated that. So again, here in R, we're able to do all that, the same thing. All right, so in example 5 here, again, suppose we want to retrieve only the unique neighborhoods from the ANB table, right? So again, here, we're just going to do that, and then we're going to be using this keyword order by, right? And then we can order by the neighborhood in ascending order. So order by here is just another keyword used to sort the results in ascending or descending order, right? So let's look at this. So let's run this. Again, we can see here in ascending order. So by default, it's ascending order. So if I remove that, that's the default. So nothing changes here. But if you want to reverse the order, then you have to specify descending order. So we'll start with anything from Z going all the way to A. And again, here we just retrieve all the distinct neighborhoods. And we have also specified that we want to sort it down, sort it by either ascending or descending. So by default, if you don't specify, by default it's ascending, right? And you can see all these are the different unique locations or neighborhoods. Again, here, let's say want to select everything from our table, select star from NB table, order by price, and then ascending, right? So again, here we can see, if we scroll across here, again, we've selected everything, but for importance here is the price. So I think it'd be much more useful if we reverse this to descending so that we can see starting from the most expensive going down. So we can see there are some use cases where we have price equals to 0. Again, that means that you can do a bit of so actually there are some nightly rooms that are approaching $8,500. So this is just an entire home or apartment. There's even a private room that probably at 10,000, right? And minimum nights you can stay here is maybe 100 or 5. So very, very intriguing here. All right, and again, it's the same thing. So, but again, you can also use something called between here. So again, let's look at that keyword here, between. So this operator selects values within a given range, right? Could be numbers, text, or dates, right? And this is the syntax. So we just use the same template, select from, where, all these select column names, tables A and B, then where is the condition, and then between maybe this date and this date, or whatever variable we want to use. So in our case here, we want to select, right? We want to extract from our table all the columns for listings with a price between $100 and $200. To do that, we're just going to use this between, right? And then we order this by the number of reviews, right? And reverse the order to descending. So once we run that, we can see we have around 18,000 listings, right? That satisfies this condition. So we can see that all the prices here range between 100. So if I keep going here, you can see they range between 100 all the way to, so I can actually change this to 200, or maybe, let's see, between, let's say 9,000 and maybe 10,000. Let's see what happens here. I don't know if we'll get some records. Yep. So that means these are very expensive apartments or homes. In fact, you can see you can find this in Manhattan and Queens, right? And you can see these are the different neighborhoods, very expensive, right? So meaning that we only got 6 listings. So that satisfy this condition. So very expensive apartments for sure. Yeah. All right, that's it. And then lastly here, again, we can also retrieve unique host names from the host data table. So again, the template here is select distinct, then the column name that we want to effect the changes on or affect the changes on is host name from A and B. We do that again. You can see we have 11,344 unique host names, right? The same thing you can achieve here in R on our data frame. So again, we say Airbnb $ to extract the host name here. Again, this will be truncated to the nearest, again, 1,000. But again, we can see here SQL can be very powerful. So we already have all this. So we can scroll through all these different rows, right? This just gives you a sample. So pretty powerful. The next cluster here is group by and aggregate function. The group by here just is used to group the rows that have the same values in certain columns, right? So this is very useful, especially when you want to perform calculations on group data. So let's look at the first. Let's look at the first example. So again, here the first select here neighborhood group average price as average price from NB group by neighborhood group. So let's look at each of these. So the first one here is select neighborhood group, right? So what this code does is to select the neighborhood group column, right, which is this, all right, and then calculate the average price, right? So in fact, let's go by here and look at group by. So group by is an aggregate function. So if we look at group by, this is just a statement often used with aggregate functions like count, max, minimum, sum, and average to group the results set by one or more columns, right? So we're going to use this aggregate function called AVG, which is just it's called average. So again, here we want to calculate the average of the price column for each unique value in the neighborhood group, right? So the result here will be aliased as AVG price. So we use as here to create an alias where we're going to store the result of all this, okay? So once we have that, the group by clause here, right? What this does is used to group the data by the neighborhood group column, right? So we run that, and you can see we've returned all the unique neighborhood groups. So we have group Brooklyn, Manhattan, Queens, Bronx, and all that. And we've already computed the average price for all the entries in Brooklyn, the average price for all the entries in Manhattan. So this aggregate function, very powerful. So it can perform max, you know, and then you can see here AVG price. So this is an alias that kind of stores the, all these values that is applied on all the different groups here. So as you can see, if you find the distinct, groups in the neighborhood group here. So if I do this again here, so for example, if I just say unique over here, NB, right, A, B, and B, let's see, A, B, and B, all right. So $, then neighborhood group. You can see again, we only have 4. So this actually corresponds to that. So we're just taking the average price of all the entries in Brooklyn. Okay. Another example here, just to demonstrate that. So again here, the only thing we've added here is max. So in this case, this part of the query here, we're just saying we want to select from the table NB. So we have 3 columns, right? So we have neighborhood group, we have average, we have price, and then we have the AVG price, which just, so this part of the code here just calculates the average of the price column for each unique neighborhood group, right? Just like previous. And then the max here, the max number of reviews here, calculates the maximum value of the number of reviews column for each unique neighborhood group. So pretty much complex, but also kind of aggregates all this together. And then the as keyword here, right? It's just a keyword here used to alias the calculated columns. So for example, the values of all this average price will be stored here, a new column, and then the maximum number of reviews will also be stored in this new column. We are calling max reviews, right? Respectively, right? So then we want to group by this. So if we do that, again, we can see we have this. So in addition to this column, we can see the maximum reviews, right, for each of these neighborhood group. Okay, so actually there was a listing in Brooklyn that had a maximum reviews of 488 and so on and so forth. All right. So the next here, the next SQL statement, again, we have having. So again, we can find it here. It's just a clause that was added to SQL because the where keyword cannot be used with aggregate function, right? And this is just a syntax. You say select some column names from table name, give some criteria, group by, having, order by. So that's just the syntax. So again, everything remains the same. The only thing here is to explain a little bit more about this. So the having part here, again, the having here, this just part of the query specifies a condition to filter the groups after the aggregate is performed. So for example, here, the having here is used to filter the groups based on the condition. The condition here is average price that we already calculated here is greater or equals to 50, right? So which means only groups with an average price of 50 or higher will be included in the result here. So as you can see, so the first thing is to get all this, and then we filter based on this. So once we run that, you can see it will only include results that actually meet that criteria. So maybe if I change this to 100, let's say I change this to 100, right? So let's see what happens here. So we expect Queens and Bronx to disappear. All right. So again, you can see it will only include everything that kind of returns the results of this, but meets this criteria. Yeah. Again, that's the same thing we've done over here. Okay. So here, sometimes you might get this warning here, decimal MySQL column numeric. So I just did some modification here to use this cast. If you come across that error, so we just want to cast this as a char. Again, then when we run that, you don't have to, you don't come across that warning. Yeah. All right. And then lastly here, for having, we can already see that we can use also having here. So this part of the query here, again, what that means is that we can filter based on some conditions. So we filter the groups after the aggregation is performed, right? So in this case, we have 2 conditions based on 2 conditions. So the number of listing, which is just a column. So if I just do glimpse over here, glimpse A and B, right? So you can see here number of reviews, right? So what we have here, so again, so actually this is an alias. So all right, let me just quickly explain that. So at the top here, you can see we have here a count, right? So everything remains the same, but now we have count as number of listing. Okay, so here the count here just counts the number of raw listings for each neighborhood group. Again, this just counts the number of raw listing for each neighborhood group. Okay. So the S, yeah, this keyword here, S, yeah, is used to calculate the columns as average price here, yeah, and the number of listing over here. Okay. So again, once we have that, so if you run this, you can see number of listings, right, for each of this group. So very powerful. We've done aggregate function for average price using this average function, and then we also use the count. So if you remember here, group by, if we come across, we click on group by, you can see we can also, we've used count over here. Yeah. So pretty much powerful here. And then again here, you can run this again. What that means is just getting the total count. So for example, here we want to get the distinct occurrences of values. So in our case here, we want to get how many, the number of count for this neighborhood group, right? So we have 2,000, actually 21,661 total count, right? That meet this criteria, actually Manhattan. So this is very interesting. So I could change this to maybe, let's say Brooklyn, right? So we can see the listings in Brooklyn also is almost similar, 20,104. Again, if I just again change this to Staten Island, so returns. So here we have very few listings. So as you can see here, we can easily count the number of distinct occurrences or values from this neighborhood group, right, as part of the listing. Okay. All right. Lastly here, as you can see here, we can also retrieve the host ID and average rating for hosts with more than 10 reviews. So this SQL statements allows you to answer questions like this, real world questions like this, right? You can see here, we pass the host ID, use the average function on the number of reviews, get the average, okay? And then we store that as AVG reviews from NB table, and then we group by host ID. But now here, we now, based on this aggregate function, the resulting aggregate function, we now perform this halving, right? And then we count, we want to count from this result here. We want to count everything that's greater than 10 and everything that also evaluates to average number of reviews that's greater than 4.5. Okay, so with that, you can see again, we have all this. So average that, so just here, we just want to get average reviews that are greater than 4.5, right? So you can see all this kind of satisfy that condition, with this being the lowest, I believe. Yeah. So pretty much. So again here, so in this example here, the review table is just to retrieve the host ID and the average rating, right? Average rating or average number of reviews for hosts who have more than 10 reviews. Okay, so this is just for hosts that have more than 10 reviews, right? So that's what this means. And then an average rating, which is number of reviews that are greater than 4.5. So we can actually aggregate this together and filter based on some two conditions here. Okay, so this is what SQL can do for you. Then we also have like over here. Like also is another operator. So if we go to like here, we can see it's just an operator used to in a where clause to search for a specified pattern in a column. Of importance is over here. So if we put the what do you call this? This is percentage sign, right? After the character, that means find any values that start with A. If it's actually before the character or the letter, that means we want to find any value that ends with A, right? So let's start looking at that. So we want to select everything from our NB table where name is like, then we want to say percentage, luxury, percentage. So what this means, anywhere in this name that has this keyword or luxury. So if we do that, you can see here in the name, this is somewhere towards the end. We have this at the beginning, but let's say if we wanted to have that at the beginning, so we can remove this. You can see luxury. So it'll just return everything that ends with luxury, right? What if we want to have everything that starts with luxury, right? So we just put that at the end. And we can see from here, it just returns every listing that have luxury beginning with luxury. Okay. What if we want to find another name that starts with cozy and ends with apartment? So we just put the percentage sign here in between. So if we run this, we can see it starts with cozy and ends with apartment. And again, so we can try different things based on this. So the like can be combined with this. With also this underscore here, you can see any values that have R in the second position. Okay. And then distinct here is just a keyword to retrieve unique values. We've already seen this a lot. Again, we've seen how we retrieved all this. We have Brooklyn, Manhattan, Queens, Staten Island, and Bronx. These are all the unique groups, right? So you can change that to, again here, if I change this to maybe, let's say, glimpse, right? And B&B. All right, so we can change this maybe to room type. So room type. Yeah. So you can see here we have private room, entire home, and shared room, right? Another thing that can interest us is maybe neighborhood, right? So neighborhood here, if we do neighborhood, remember here, we have to use OUR neighborhood. Yep. Again, here we have 221 unique neighborhood, right? And all these are spread across the different neighborhood groups. Yeah. Yep. So that's how to use distinct, right? Again, yep. So that's what we have here. So that's how you can use distinct, right? Yeah. So that's what we have here. Then the next thing here is update. The update statement is used to modify data in the database. You can use it to update existing rows based on certain condition, right? So suppose here we want to update the price of all listings in Manhattan that have a minimum nights value greater than 3, right? So let's say we want to update that with the price, add 50 to the price, right? So to do that, we can, first of all, let's look at the update statement here. So if we go to update statement, it's just used to modify existing records in a table. And this is actually the syntax of how to use it, right? So I just added this. First of all, let's retrieve all the neighborhood group, right? The price minimum nights, and we want to provide a condition here where it's Manhattan minimum nights greater than 3, just to see what we have here for price, right? But now we want to say that we want to add 50 to all these prices that meet this condition, right? Where the minimum nights is greater than 3. Okay. So if we execute this, let's see what happens. All right. So we go ahead and do this again. You can see we've added 50. So in fact, let me run it again now so we can see the difference. So we can see here is 130, 185, 170. So we want to add the price 50 for all that meet this criteria. It's in Manhattan and has minimum nights greater than 3. So we run that again. It will add the price 50. So you can see this 180 change to, 130 change to 180, and so on and so forth. So if I run this again, it will just keep on updating with 50. So let's look out for this 300. We have 235 here. So if we update that, you can see we have now 285 and we have 350, right? And so on and so forth. Again, we have this replace. So replace here is another SQL function, okay, that just replaces all occurrences of a substring within a string with a new substring, right? And this is actually the syntax, right? But let's look at an example here. So we can say replace into NB, the table. So we specify the columns that we want to replace values with, which is ID, name, host ID, availability 363, with values 3831, and we want to insert the following in the name of our listing. And then the host ID is 469, and availability we want to say is available 365. But before we do that, I just was curious to see what happens here. So first of all, let's retrieve that. You can see we only have this. So once we replace, it will just check if it doesn't exist, it will insert a new, right? So let's go ahead and do that. So we run that. So again, we run this and we can see now we've actually inserted everything that meets that based on those columns. But now you can see now available 365 and so on and so forth. So this is what replace can do. Lastly here, as we conclude, the delete statement is used to remove data from a database. We can use this to delete rows based on certain conditions. Again here, we can find delete statement over here. It's just used to delete existing records in a table. So we come back here, we can see we have select star from NB, where number of reviews equals to 5. So here we have 1,618 records that meet this criteria. Okay, but now here we want to delete all those listings that have no reviews, meaning that where number of reviews equals to maybe 0, maybe 5. Let me just let's see number of reviews equals to 0, for example. So if we run this again, you can see we have 10,000, right? This is quite a lot. So let's just increase the threshold here. Number of reviews. Okay. So just for demo purposes, we don't want to delete valid documents, right? So you can see here we have 1,618 that meet this criteria. So if we go here, number of reviews, so we just go here, all these meet this criteria, right? You can see they all meet this criteria. But now we want to delete that. So again, once I execute this, I go back and try and retrieve that. It just says nothing, there are no 0 rows, right? So that's just what delete statement does, right? Suppose now we want to delete from NB table where price is greater than 2,900. But first, let's retrieve that. So we use select statement. And you can see we have 56 rows that meet this criteria. So if we go to the price here, where's the price? All this are above 2,900, right? So if we use this to delete that, so let's go ahead and delete that. We run this again, it doesn't return anything. So we've already deleted that. Okay. And then lastly here, we're just gonna drop. This is you don't want to use this. This is actually permanent, and what this does will drop the entire schema from the face of our, rather it will drop our table from our schema, right? So if we do this, so if we run that, so next time we want to run this, we'll get an error. The table does not exist. And we come here, refresh that, the table is gone, and that's it. So that just concludes our demo here. So in conclusion, in conclusion here, let's see, not yet. Let me just rerun this a little bit. I just wanted to show something here. So I'm just gonna create the connection here. Just create the table again. And then I'm just gonna write this in there. Right. And then over here, what I just want to show here real quick is how to backup. So let's say we want to backup. So it's important to always ensure that you can backup your database, right? So to do that, we can use that using this SQL. So we can create a table, call it this, right? As, then we select all the contents from our table, existing table. So if we run this, so if I change this maybe to 05, for example, and we run that, so this will be automatically stored in our, where we're running our .rmd, and we can see it should be somewhere. Let's see, that should be somewhere. Let's see, this is MySQL. Where is that?